G'day, welcome to the fourth video on integration. In this video I'm going to look at integrating trig functions, which is 7.3 in your textbook. Now when we did a differentiation of trig functions, let's just stick with sine and cos at this point. We knew that the differentiation of sine x goes to cos x, and the diff of cos x goes to negative sine x. And I guess, it kept going. The diff of negative sine x is negative cos x, and then negative sine x goes to sine x. What I want to do now is, instead of differentiating to reducing, I actually want to integrate, which means all I do is I do the complete reverse. So integrating sine x goes to negative cos x. Integrating negative cos x goes to negative sine x. Integrating negative sine x goes to cos x. And integrating cos x goes to sine x. I guess the general rules are integration of... actually I've got them down there. The general rules for this are, when you integrate a sine function, it becomes negative 1 on k cos kx plus c. But when I integrate a cos function, it becomes 1 on k sine kx plus c. So it still changes from cos to sine to cos, but the negatives are a little bit different. It might be helpful for you to have this little table there in your cheat sheets, or in your bound reference. But I would also encourage you to kind of learn it by memory as well. Okay, so if you remember one way, then I guess you can just do the reverse to get the other way. Okay, so for example, I've got this one here, the integration of sine 3x dx, and that becomes the sine turns into a negative cos, and I get this thing at the front here, this constant at the front, because I divide by the derivative of what's on the inside. That's what I was doing up here. So divide by the derivative of that, which is just 3, so it's negative a third cos 3x plus c. If I've got something that looks a little bit more ugly, but it's roughly the same, when I integrate negative cos, it stays negative, but it turns into a sine function. Okay, and I get the diff of the bracket, which in this case it looks tricky, but the diff of that is just 1 on 4 because the pi is just a number. So it becomes negative a quarter sine, and I don't change the bit inside the bracket. So sine of 4x minus pi plus c. Okay. For this example, I've actually got two different things going on at the same time. I've got an exponential and I've got a sine function as well. So I do the exponential first. The antidiff of a sine of e to the 2x becomes 1 on 2 e to the 2x. And when I antidiff negative sine, it becomes positive cos. Okay, so it changes from sine to cos, but the negative changes to a positive. The diff of x on 2 is 1 on 2, and then I do 1 divided by 1 on 2, which ends up becoming 2. So I get 2 plus 2 cos x on 2 plus c. For the next example, again, I've got another one where I've got two different functions together. I've got 4x squared plus 2 cos 2x dx. I do the 4x squared first, that becomes 4x cubed on 3, and a positive cos graph integrated becomes a positive sine graph, or sine function. And I've got 2 cos 2x, but when I do the diff of this bracket here, I get 1 on 2. The diff of here is just 2, but then when I put it in the formula, I get 1 on 2, and then I multiply it by this 2 here, so it becomes 2 times 1 on 2, and I end up just getting 1. So it's sine 2x plus c. If you're unsure of it at all, just diff this function here, and you should get back to your original function there. Okay, so the diff of sine 2x would be 2 cos 2x, which is back there. Okay, so hopefully this video has helped in terms of differentiating sine and cos, anti-differentiating sine and cos. For this course, we actually won't be anti-differentiating tan. I guess you can do it on your calculator, and let's just have a go at that now. But you won't be expected to know this. So anti-differentiating, so shift plus to get the anti-differentiation sign, and then tan of x, and we end up getting that crazy thing there. So we won't be expected to know that, but obviously you can do it on your CAS. So yeah, hopefully that's helped. In the next video, we're going to look at anti-differentiating 1 on x. So thanks for watching, and I'll see you next time.